Hello, fellow students. Today we are going to talk about matrices. So first, what is a matrix? It's a rectangular array of numbers arranged in rows and columns. So, for example, this is a matrix with 2 rows and 2 columns. We usually label matrix by a capital letter and also bold it if you can. This is only in digital case. You don't need to bold it if you handwrite it, but you need to write a big M. And also, rows are very easily defined. It's counted horizontally down. So this is 1, 2, 3 rows. And the columns are counted vertically to the right. So this is 1, 2, 3 columns. And if a matrix has m rows and n columns, we say that it has order of m times n, or its dimension is mn. So for example, this matrix is a 2 times 2 matrix. Because it has 2 rows and 2 columns, its order is 2 times 2, and its dimension is 2, 2. So, after the definition, we are now going to talk about the operations of matrices. So to add or subtract two matrices, we simply add or subtract the corresponding elements. So for example, if you want to add these two matrices together, you will get this resultant matrix. This number on the top left is just simply this plus this of the top left number of each two matrices respectively. And similar for this 4, it comes out of this 2 plus this 2. But you need to be aware that the two matrices must be of the same dimensions. So in our case, these are both 2 times 2, so they can be added together. You can't add a 2 times 2 matrix by a 3 times 3 matrix. It just doesn't make sense because a 3 times 3 matrix will have like extra row and a column here, and you don't know what to do with them. And you also may have observed that these two matrices are actually the same. So what we're doing essentially is just multiply this matrix by 2. And this also leads us naturally to the multiplication of a matrix by a number. We just multiply all the elements by a number. So if we want to calculate 2 times this matrix, we just double all the numbers in the matrix. So 1 becomes a 2 and 2 becomes a 4. But there's a caveat here. For division, you must write it as multiplying by the reciprocal instead. So if you want divide by 2, you must write it as a half, because timesing by half is the same as divided by 2. And you do the same thing. You scale all the number here down by a half. So 2 divided by 2 is 1 and 4 divided by 2 is 2. The reason for that is if you write your dividing by 2 like this, it doesn't really make sense. Because a normal fraction is defined as a number over another number. But now you put a matrix for the numerator, so it doesn't really make sense. And now we have more definitions. Sorry, there's a lot of linear algebra jargons in this chapter, but you need to know it. And I believe you can remember them all if you just do a lot of questions. So first thing is the zero matrix, written as this big bold 0, and it's defined as a matrix whose elements are all zeros. So you just put arbitrary dimensions of a matrix and put all zeros into it. And why is it called a zero matrix? Because it will not change another matrix when added to it. This works similar to our normal number 0, as when you plus 0 to any number, you will not change the number itself. This may seem like boring, but it's actually needed because you need the similar of 0 element in matrix as well. And the next one is the identity matrix, written as this capital I. It's defined as a matrix of 1 on the diagonal and a 0 elsewhere. And it must be a square matrix. So it can be 2 times 2 or 3 times 3, but it can't be like 3 times 4. And why is it called the identity matrix? Because it will not change another matrix when multiplied to it. So it works similar to our number 1. As when you multiply it to anything, it gives you the thing itself again. I just said that the identity matrix will not change a matrix once you multiply by it. But actually, what do I mean by matrix multiplication really? How do you multiply two matrices? Well, the matrix multiplication algorithm is very different to our normal number system. Main difference is you cannot just multiply two arbitrary matrices together. You need to first check the dimensions. And the rule is as follows. The number of columns of the first matrix must be equal to the number of rows of the second matrix. And the resultant matrix will have the same number of rows as the first and the same number of columns as the second. And now this may be a mouthful to you, but written as symbols. This means that if the dimension of A is AB, so it has A rows, B columns, then you have dimension of B equals BC for AB to work. So basically this 2B must be the same. And the dimension of AB is AC. So it's basically these A rows and these C columns. And for an example, we have this. First one is a 2 times 3 matrix because I have 2 rows and 3 columns. And if you want to multiply this by anything, the second one must have 3 rows because these 3 has to be the same. So it has 3 rows and it has 2 columns. So the resultant matrix will be this rows and this number of columns. So it came out to be a 2 times 2 matrix. For the specific numbers in this matrix, I will talk about later. But for now, you just need to remember these rules. The other example is basically you swap these 2 around, and then you have 3 times 2 and multiply by 2 times 3. So these 2 are the same. It's legal to multiply them together, and the result will be 3 times 3. And you may have noticed that when you switch the order for multiplication, the product actually came out to be different. You have this different number of dimensions, and the numbers in them are also different. And this leads to a very important fact in matrix, is that A times B is not the same as B times A. This is very different to our normal numbers, as when you have 2 times 3, it's the same as 3 times 2. But in matrix, if you switch the order, the result can come out to be very different. And you must keep this in mind if you are doing some algebraic stuff with the matrix, because you cannot just simply merge AB plus BA into 2AB. That's very important. You need to remember that. After checking, we now need to actually perform the actual multiplication of the matrix. And the way to do that is, if you want to find the element in the row I and the column J in the resultant matrix, you need to multiply all the elements of the ith row in the first matrix by the corresponding elements in the jth column of the second matrix, and then add them all up. Now this is another mouthful to you, but don't worry, I will show you a lot of examples to help you get used to it. This matrix multiplication might seem hard at first, but after you do a lot of practice questions, it will be very easy to you. The example I want to give you is just from our last slide, where you multiply this 2 times 3 matrix by this 3 times 2 matrix. And you know the result will come out to be a 2 times 2 matrix. And it's a good habit to write the matrix and its dimension out first before you work out the numbers. Now let's focus on the numbers. So for example, the top left element, so this first row, first column in the resultant matrix, it will be the sum of the products of the first row, so this 1, 2, 3 of the first matrix, and the first column, also 1, 2, 3 of the second matrix. So you multiply the corresponding elements together, so 1 times 1, and 2 times 2, and 3 times 3, then you add them all up. So you have 1 plus 4 plus 9, which is 14. This tells you that the elements in the first row and the first column will be 14. And similarly, if you want to work out the elements in the first row and the second column in the resultant matrix, what you do is you select the first row of the first matrix and the second column of the second matrix, and basically you do the same thing again. And it's also 1, 2, 3 times 1, 2, 3. So the result will be 14 again. As you may have noticed, the answer is actually 14 all the way for the 4 elements. Now let's do another example. It's the one from the previous slide. Just switch the order of these 2 around, and it will give you a 3 times 3 matrix. So for the first row and the first column, 1 times 1 plus 1 times 1, which is 2. On the first row, second column, so it's this row times this column, 1 times 2 plus 1 times 2, so it's 4. First row, third column, same thing, this times this, 1 times 3 plus 1 times 3 gives you 6. And you can see a regular pattern here now. For the second one, second row, first column, is this second row and times this first column. So it's 2 times 1 plus 2 times 1 is 4. And the second row, second column, this times this, 4 plus 4 is 8. And you can sort of see the pattern here. So it's 1 times 4, 2 times 4, and this will be 3 times 4, so it's 12. And the same thing, very similar, is also for the third column. I will leave it to you for an exercise. You can work out the third column by yourself.